sorted with the merge sort thing, and then we can move to quick sort. So basically, the revision of recursion itself, right? So, like, if you have these trees, so you already know now why I tell everything is recursion. So, the names are different, and the picture is same. Hi, Asim. Okay, so okay, let's take a minute, guys. I guess, and then we are good to go, right? Okay. Here goes the message. Guys, session has started. Please join. Okay. Send the message and some other arrangements has been done. Okay, am I ready to share my screen? Okay. So one more site to be open. Code Chef. And here comes our ID. Okay, let's share the screen now. Okay. So is the screen visible to you guys? Okay, thank you. So a quick overview what we were doing so that we can begin again. And let's welcome our new guest. Okay, so here we go. Where were we? Okay, so we were now talking about an array. Let's say that three. So taking an array, right? Nothing else. So 3 2 5. There goes the 8, and let's say 4 1 is the cycle complete. 1 2 3 4 5 6. Okay, and let's say 7 also. Okay, the idea of merge sort was have a number, divide it into halves. Okay, divide it into two halves. Okay, so how to divide into two halves? What we did? Anyone remember? Logical division, right? So you're having the array. Now I say you to divide. So let's say that I starts from 0, goes till 7. Okay, now the logical division would be I equals to 3, right? Now at this point we are not exactly copying the array into halves. We are just putting some marker over here. This is the mid, and the traversal would go something. So this is what dividing the array means, right? Next, one recursive. Okay, I guess. Okay, let's go to this again. Now coming to the point, 4 1 is here, 6 7 is okay. Now, so here was the first mid we got for this one, right? And similarly, there is something else we will be getting. I equals to 1. Okay, so this is this made. So 0 1 2 3 3 by 2, then this is 1. Makes sense? And I equals to 2 equals to I equals to 3. Similarly, 7 till not 7 exactly, it would be 4 and then 7, right? Okay. Now, so this was the first division for merge sort. This is a second recursive call, and the final recursive call for single elements, right? So for single elements, okay, and here it is. Now, the logic was what was the logic, guys? If we get a single element, it is already okay, correct, very correct. So what we are trying to achieve here is, so our base case becomes If my array length is 1, return it. Okay, that's it, nothing to do. So I want, so whom to return? Who has called the function, right? So who called the function? The previous one called the function. Okay, so let's do it below. Don't, like, not overwriting this part. So maybe we can do something like, now this part, reaching this stage, this array will return 3 because it's already sorted. Now this array will return 2 because it's already sorted, single elements, right? Now here comes the point. Till this part, what we were doing is what we called is merge sort callbacks. Sorry, not callback. It's calls, recursive calls. Now here comes the point. We already have studied about a merge function, like how to merge two sorted arrays. Take two pointers on the arrays. Okay. Try to compare I and j. Very easy. Store in the third array. Move the pointer with the smaller element because it's already included, right? So that's what the logic. Similarly, talking about this two array, we can simply do this part, right? So simply we could have done. So these two array will contribute and combine to this. Similarly, 5 8 over here, 1 4 over here, 6 7 over here. Now we'll talk about these two and these two. So here comes the merging part. Okay, so 2 3 5 8, no change in the sequence, right? And I guess no change in sequence here also. Finally, merge of two sorted array, which we already know, will fetch us the final sorted array. So which will be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is what we'll be getting at the last stage. Okay. This is the answer. Okay. Any doubt till here, guys? You can say it. Okay. So please don't hesitate to, like, to keep asking keep asking the questions. Okay. So creating a merge sort function, here is what is needed. Here goes our array. Okay, so we can take any arbitrary array we want. Okay, 3, 4, let's say 1. Here goes 2. Okay, 6, 7. What left? 5. Then 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, makes sense. Yes. Now here is our array. Here goes the logic. Supplying the array for merge sort. Okay. Now, if you remember, we pass the index over here. Okay. The start index and the end index itself. Okay. So here goes the end index. The initiator call. Okay. Now, writing the logic. So don't worry. We'll just have a dry run every time I write anything. So void nothing to return. Okay, because we will be changing the same array. No copy of array is created. Modifying the same array, right? Swapping the elements here and there, and that's it. So no need of any different array to be returned or to be made. Here goes our array. Okay, and here's the not int st comma int. So okay, so before I proceed, what should be the base case, guys? We just discussed. Length is equals to 1. So how can index help us with length equals to 1? When r is start and end. Okay, so when something like this happens, so now we know that it's time to return. Make sense, guys? Guys, is this part getting clear? Okay, so if not, you can just ask. Now the point is, what should be the recursive calls? Okay, so deciding the base case, one of the step. Second step, what should be the parameters, and third is number of recursive calls. Okay, so if we exactly see, so there should be every time a mid calculation, and the two halves of the array should be using or like called for merge sort respectively separately, right? So find the middle and make the merge sort call. So let's do that. So this is the point, right? So you have to convert your logic into code. Okay, so that's how like you get to learn. Now you can do something like this: st plus en divided by 2, right? Okay, makes sense. So here we are, and so for calling the half of the arrays for two merge sorts, so what should I? So what should be the parameter here, guys? What should I write in the parameters? The logic is call in the first half, call in the second half, and merge the array. That's it. What should be done here? Okay, this is not so difficult, right? So we already discussed. So we are not going to make the copy of array. Just the index will help. So figure out start an index, and that's it. Okay. Okay. So I'll just proceed. If you guys, I really hope you guys provide some input. Otherwise, anyway, let's see this. So we are not like copying the array using the same array which we were supplied. So that's the same thing. The start remains the start. Okay, and the mid becomes a new end. Okay, why mid becomes a new end? Because we are picking half of the array for merge sort, half of the array for merge sort, half of the array for merge sort. So this half of the array for merge sort, this half of the array for merge sort, this half of the array for merge sort, this half of the array for merge sort. When it is a single element reaching to the point for merge, okay. So when they return from merging these two, so merge sort this, merge sort these. So we have two sorted arrays, and we have to merge those two sorted arrays. So what is the agenda of merge sort? You have two sorted arrays, okay, and you have to merge them. Two sorted array means two merge sort called, okay, calls. So for example, this is the first call, right, for the first half. Similarly, there goes the second call, okay. Now what should I write here, guys? At least you can tell this one. Okay, and array dot length or end, right? Okay, it's the same thing going. Now what should be the step here? Merge, right? Sort first half, sort second half, merge first half and second half. Okay. Now merge function is really which we have already completed. Let's so what was the logic? Okay, so let's see the logic. So static void merge, and here goes our array. Okay, and the start and the end. Right, there we are. Okay, now we'll say that if st is equals to En, st is equals to En, this can be a base case, right? Done. That's it. If this is not the case, right? So both halves are sorted. So both halves are sorted. So which halves? So mid is equal, not mid, it's mid. So mid is equals to start plus end by 2. Okay. And the next is merging two of them. Okay. So let's merge them. Here goes the first pointer, which will start from starting. Here goes the second pointer, which is I'm starting from the next one. So there's a question for you guys. I'm starting from the start and I'm starting from the second, the middle part. Why am I not writing zero here? Why am I mentioning start? Why not zero? Okay, correct, very correct. So we are not sorting the array every time from the start. We are at any point in our recursive step, right? So we do not exactly know which part we are going to sort. Okay, that is why start is written. Very correct, very correct. Okay, so let's proceed with the logic. First pointer, second pointer. What we do, while I is less than equals to mid, right? Not this. So we'll go with I till mid, and J is less than, and J is less than equals to n. Let's try to merge two sorted array. So for example, let's take an example. It's always better. Example helps always. Not zero. Let's say 10. So this is one sorted array. Okay, 3, 4, 7, 10. Very sorted. And 2, 4, 7, 11. Okay. Get rid of duplicates for now, as of now, so that we don't end up confusing ourselves. Okay. So logic for merging two sorted arrays in a single array is put a pointer. So one is at 2, another is at 3. Compare it. Okay. So compare 2 and 3. Whatever is the small will go first. Whatever is small will go first. Okay. So should we be using the uh, third array, or it's just fine, I guess. Okay, we can use our own array also. No need to be going with another array. Maybe this will be working fine. Now key is pointing to start in the same array, right? So 3 and 2 are here. Okay. Now the point is, uh, okay, so should we swap or what? Hmm. Okay, this is a question. So, should we take this array, make this one, and again copy in this, or will this be working fine? So, I want to swap. So I want to move two over here and move the pointer. Okay, so for that I have to keep three somewhere else so that I do not lose that element. Okay, any other options? Yeah, we do have an option for something like this. Int array one. Okay, so we'll have one more array where we'll keep copying our elements. Okay, so int start. Okay, so ending minus start plus one would be the size, I guess. So 0 to 7 would be, so let's say that 0 to 7. So 0, so 7 minus 0, like 8 length array we want, and plus 1. So 7 minus 0 plus 1, so it would be 8. So 8 length array would be there. नेट ऑन है क्या पापा? नेट ऑन है क्या आपका? हाँ बस एक 2 मिनट के लिए कर दीजिए। नेट खत्म हो गया। इसमें है। तो पासवर्ड okay. So sorry about the network issues, guys. I will start sharing the screen again, and here we are good to go. Okay, so I guess we're good to go. Now, so the point was, in order to merge the two sorted arrays, which we'll be getting from these two, what we can do is we can keep our pointer at I and j, first array, second array, keep a main pointer which will be traversing through the array, okay, and create a new array where we store our sorted element. We'll replace this array. We'll place this sorted array in our original array once we have done. Once we are done with the complete sorting, complete merging of two sorted arrays. So this part is very easy, right? So the merge part is we have already done, something we are already familiar with. Okay, so I hope that doesn't confuse us. Okay, so I should be less than mid while traversing, and j should not surpass the end. Okay, so here is the logic. I will say if by if array of, so let's say array of I is less than array of j. So here it goes. Okay, and we say that array I. Okay, so array 1 exactly, array 1, and what else? Key can I guess start from 0, no issues. So there's a trick, so you can do something like this. It will automatically increase the index from the current index, right? And we can say array of I. Okay, so we are storing the smaller element first and increasing of the. Similarly, here comes the second condition, and okay, no, so command Z, command copy, okay, and here we are good to go. Okay, so let's say that there is a if condition. Do we need this? No, we do not need this at all. So either this will be greater or it will be equal to or greater, right? So here goes j, and it will be j plus plus. Guys, is this part clear to all of you? Okay. So picking up the a smaller element, putting in the array, and increasing the index of the array every time. Any doubt till here, guys, in the loop? Okay, I guess that's fine. And here is the next thing which we need to keep in mind. What happens in this case? So we are having two sorted arrays, right? One pointer here, one pointer here. So 2, 3. 2 goes first, 3 goes second. Now the pointer is at 4 and 5. So 4 goes first, okay? Then pointer is at 7 and 5. Then 5 goes, because 5 is smaller, pointer goes to 8, and here to 7. So 8 and 7. So 7 is the smaller one, goes here, pointer goes to 10, and here it is at 8, right? So pointer goes to 11, and here we have 10, right? Finally, 10 comes in the array and pointer goes out, loops break. But I guess we missed this element. Are you guys getting the point? What can be the issue with this loop? Okay, so if I do the same logic, if I come to 11 and this has been included, so we are increasing the index once it's included. If I do the same thing, the loop breaks because of this condition. Okay, so it cannot go past mid and it cannot go past end. So what should we do here? So I guess first of all, you guys are getting the what you can say, the problem which we can face with this loop. Okay, see this logic. If I say what's the condition here? It is and. Okay, now it's not or, it's and. So either this is true. Okay, so either one of them is true or one of them is false. Sorry, so loop breaks, one of them is false. So only one of them may be false. Maybe two of them is false, but only one of them is false. It means that one of them is still holds true. Either the I hasn't reached its mid yet. So the same logic, nothing to be worried for, and it goes here. Similarly, there comes a second loop with this logic, and rest I think we are good to go, right? So here it comes, and J should be greater than, while J is not greater than, it should be less than or equals to. So what's in my mind? Okay. Okay, let's welcome our guys. Okay, and we are here again. Now, okay, so it's k plus plus, and it is now j, and this goes as j plus plus. Okay, so this will solve our problem, right? So either of them is still holds true, so we have to push that element to the array. Okay, so merging two sorted arrays. So if you carefully look at this while loop, it says that j is less than end. So even this loop has break. J is less than equals to n. This will still run. Okay, so this will still run, and this j will be allocated over here, and then j moves, and now it does not move. So that also becomes false. Guys, is the solution clear to all of you? Any doubts still here? Okay, so I'll take that as no, and I guess we're good to go. So it comes. So k. Okay, now so we have the array and we have to copy in our own array. Okay, so traversing over array 1, while or for. Okay, anything would do the job. So okay, now let's say that index is equals to starting from 0, and index is less than k, which is the total size of the array made. And here we just copy our elements. Okay, okay, so start plus plus, so starting, so we are copy from the starting, and what we are copying exactly is array of I, and here goes our index. Okay, so guys, is this part clear to all of you, the merge function? Okay, so there can be any time which this is true, like the greater than case. Hmm. Okay. So it can be true or what? So let's put this part here also. So I guess we are done with the code now. Okay. So merge sort, merge sort, merge sort, merge. So whenever this happens, so either the length is one or something this happens. Okay. So we just return it. So returning. Okay. And finally, so merging on the first half, merging on the second half, merging on the first half, merging on the second half, finally reaching a single element where you just try to return. Okay, so you just try to return. So whenever you try to return, every recursive call has to face this function. Every merge sort call has to face this function, merge function. Okay, you get it from here, you get it from here, and you just go here. The merge happens because we now have two sorted arrays. Okay, so we are good to go. Let's try it out and check. So I will try to print the element. So for, and we can simply print this. That's it. Let's run this and check we are good or not. Okay, so here is first one, k plus plus. I required but int found. I required but int found. Okay, so legal initializer for int. The second one. Okay, so here is the first correction, and I guess the second one is here. I guess is going fine. Okay, so it says array index out of bound 8. So array index out of bound 8. And why is this? Okay, so here we go. So the first thing is starting is this one. And so I say that I is less than mid equals to mid and j is less than equals to en. Now if array of I is less than array of j, so include array of I plus plus, otherwise include array of j plus plus, and while I is less than mid, so I is less than mid, we are having, okay, so this thing, so we are having this. You just copied into this array, and I guess that should be working fine though. Okay, so here is the point. So it should be minus one, right, in order to be working. Okay, so because we are including counting the index over here with us, and array index of bound exception 8 at line number 46. Okay, so let's debug this part. Okay, okay. Hmm. Okay, here is the point. So it should be in plus plus, right? Okay, so we have solved our first problem, and here comes the second one. So array index out of bound exception 2 Line number 46 again. Okay, so no major fixes, just a bit of change in conditions. Yes, it should be going fine, and here we are. Okay, so we can see that we have successfully implemented merge sort code, right? So we are getting the error. Now, okay, so test it out, testing the algorithm completely. Let's introduce a zero here, a zero somewhere. Okay, so zero in the middle, and here we go. Okay, so let's see. So we are having zero in the place until 8. Will this work for negative values? And let's see. And for duplicates or not? What's the case? What's the case? Okay, so minus four, minus three, zero, one, two, three, four, four, five, six, seven, eight. Okay, I will just copy this code and share with you guys. Guys, any requirements, like any explanation in this algorithm, anything you want me to explain again, or we are fine? Apart from dealing with the number of recursive calls and what arguments to pass, I guess there is no code which we haven't already done, right? So we already know how to merge two sorted arrays. Okay, the main part. Otherwise, these two are like the same thing. Whatever we are trying to write in the logic, we are just implementing same here. So you see the magic of recursion, right? So like you just have two lines over here and the merge is doing its job, and that's it. We're good to go. Any questions till now, guys? Anything you want to ask? Okay, so I guess that's fine, right? I can just have a revision and that's it, and so on. Okay, and here comes the second one. So for you guys, let me pick up my pen. Okay, and where's it? Okay, so are we facing network issues or what? To reconnect this part. Mhm. Okay, maybe there's some issues we are facing. Okay. Okay, anyways, we can just go with this also. Let's see what we are going to learn in this algorithm and why it is important, basically. So till now, bubble sort has been done and sensor sort has been done. Um, so bubble sort, insertion sort, we just saw merge sort, right? And selection sort was done. Okay, so insertion sort, picking an element, putting in the right position. Selection sort, sorting the first half of the array. So how to do that? So pick up the minimum element, put at its, like pick the minimum element to its correct position. The second one, the third one, and so on. Bubble sort with the adjacent. Compare with your adjacent element. If one of them is bigger, move it, or if one of them is smaller, leave it. Okay. Then comes the merge sort, so which reduced our time complexity to something which we have not seen, which we'll discuss. Then comes the quick sort, right? So here is the algorithm, important algorithm, okay, which we are going to learn. What's the whole point? Point is, why so much learning, like why so much algorithm just for a sorting operations? Most of the time, like uh, let's take a real world example. There's a database, right? So you do database queries, and so, and let's say that you want any collection of users who are registered in last 4 days or something like that, right? Now, in order to like fulfill that, you have to keep your records sorted, right? So, and some things are there like sorting by email, or like something, or sorting by name and so on. So that is why we are trying to learn so much of algorithms for sorting itself. The point is, what's the point? The point is, let's take an array. So let's take it something so that we can use it in our code also. One, two, here comes four, five. Not sorted array, not a good idea. Three, okay, seven, eight, two, one, right? So one, and we are missing four. So one, two, three, four, five, six, seven, eight. Okay, so six and four. One, two, one, two, three, four, five, six, seven, and eight. Right here it is, and let's not multiply practically. So two things here. Now, starting with the logic first. So here is what quicksort says. Let's pick the element 5. Let's pick the element 5. Okay. Put it to its correct position. Put 5 to its correct position. Pick the element 5. Put the put it to its correct position. Okay. And all elements shorter than 5 lie on the left side. All elements bigger than the number lie on the right side. All elements, I will repeat again, and with one iteration. So iteration 1, itr 1. Okay. So the iteration 1, it is something like, let's pick 5 and put it to its original position. So so how to calculate the original position? Find the number of elements as smaller than 5. The next place will be of 5. What do I mean by that is 5, 1 is smaller, 2 is smaller, 3 is smaller, 4 is smaller. Okay, so we have four numbers are small. It means that the fourth index would be the exact place 5 should be sitting right now, right? So 0, 1, 2, 3, and 4. So this point 5 would be there in a sorted array. In a sorted array. So it means that 2 should be replaced with 5. The same thing is going to happen. Okay, so here goes your 2, and here comes the 5. Okay, this is the first part of a single iteration. Okay, first part of single iteration. Now here comes the second part of your single iteration. Single iteration. Just this is a just one call, one function call. You swapped your current element, you swapped your first element with whatever element which was going to be the greater than all the elements are smaller than the current element. Now 5 is here. I want this part to be less than 5, or and I want this part to be greater than and equal to 5. It means that compare 2 and 1, compare 2 and 1. Okay, so they are lying on the same position, so they are lying at good place, right? So 2 is less than 5. Very correct, very correct, so no issues. Okay, so I'll just move my pointer at 3, and here the pointer is at 1. So 3 and I. So 3 is less than 5. Makes sense? No changes. Now here comes the point. The pointer moves to 7. The pointer is here. 7 and 1. Right? So 7 exactly is not at its correct position. Because 7 exactly is not at its correct position. It means that 7 should come this side. So this is what it becomes. So 2, 3, 7 will be swapped with 1. 7 will be swapped with 1. Okay, and 6 and 4. So okay, now the quick sort says whatever be the first element is, whatever be the first element is, pick it up, put it to its correct position. Okay, put it to its correct position. The elements in the left hand side would be the smaller, and this would be the larger one. So that is what we are doing. So we are like getting two pointers over here. Okay, and we are trying to transfer it. Now one has been shifted here. The pointer moves forward. Okay, now the 8 and 7 has to be compared. Nothing. So the pointer moves forward. 6. Okay, nothing. Then 4. So you find 4 to be smaller than 5. Then it has to be swapped. Then it has to be swapped. So 2, 3, 1, and here comes 4. This comes 5. Okay, 7, 6, and 8. Now this is one iteration. So if you carefully look at the iteration, we have successfully moved all smaller element from 5 to the left hand side and all is bigger element to the right hand side. Okay. And the same thing goes on till the point where we have sorted all the elements, right? So, and how do we know that? Because our start and end index start to collide. So this is what it is. Now finding so let's say that 5 was here, right? So this is called as pivot. So we try to sort around the pivot. So left elements up like for the pivot should be all lesser than and greater and greater than equal to element should lie on the right hand side. So this is what it is needed. And finally, this is our pivot. Now we'll call quick sort on this part. We'll call quick sort on this part. Okay. So once this is done, so calling quick sort on this part and calling quick sort on this part. No need for this part because 5 is already at its correct position. Okay, and then at last we'll find that we are done with the sorting. Guys, is the logic clear for quick sort? Should we move to the code? Okay, someone wants to say something? Anyone? Okay, anyways, so let's see what would be the potential code for this one. So we are already having the array. Now here comes the quick sort. Again the same thing, passing the array, passing the start index, passing the end index. Okay, so this time let's not do the previous mistakes. Okay, and here it goes, for loop for printing I equals to 0, I is less than array dot length, and here goes I plus plus. So let's build the quicksort method. Let's see how recursion is going to make our life easier. So static quicksort, static quicksort, and here it goes. Mm, array intent start and end. Okay, and this is going to be void, right? Again, nothing has to be supplied over. So the logic says if, so here comes the base case, but before the base case the logic says int partition, int partition. Now where do we get the partition? Remember what we did? Pick the element, move it to its correct position, pick the element, move it to its correct position. Okay, so all elements on the, and keep swapping the all elements from the left hand side to the right hand side till all the smaller elements from the pivot comes this side and bigger elements go this side. So this is what the scenario we see. Okay, so this is not a sorted array but if you carefully look, this has a unique property. All elements less than 5 are this side, and all elements greater than are on this side, right? So this is what we need to take care of. Now here it goes, something like quick sort. Okay, so we will be returned partition. Okay, so we'll be returned partition by some algorithm. We'll see which algorithm will we use for this partition. Okay, and partition is applied for the complete array. Now once you get this index 5, once you get this index, rest call quicksort on the left hand side, rest call quicksort on the right hand side. Okay, so here we get the partition, and again the quicksort call. So here goes the array start. Okay, so array start and partition minus one, right? So remember, partition minus one. So partition which is already set to its correct position, we are not bothered about that, right? So we are just bothered for other elements. Okay, so this is the two API calls and the partition function logic. Okay, the partition function, whatever partition you get, you just apply it. Now, what should be the base case, guys, for this question? So if the start is greater than equals to, if the start and end is greater than equals to en, you can return nothing, right? If the start is greater than equals to en return, right? How does the partition function look? Static void partition. So it will be taking up the array, okay? And here goes the start index and the end index. Okay, so for the partition functions, guys, is the partition logic clear to all of you? What it's trying to say exactly? If anyone have doubt with the partition logic, you can tell. Otherwise, we can proceed. Now, partition logic says pick up the first element, swap it with its correct position. So here comes the pivot element. So pivot. Okay. So array start. Okay. So array start is the pivot. Okay. Now here comes the loop which will check for. Uh, Here goes the loop which will check for greater elements than pivot, or maybe the smaller event elements than pivot. Both be working fine, but anyways. So smaller elements than pivot. So we want to count the number of small elements. So how what we can do is, I guess we can simply go with for loop. Okay, so you can say as equals to 0, I is less than array dot length. Okay, and instead of going from this one, let's go to start plus one. Now, if the current element, so the current element is array of I. Okay, so if it is greater than, oh sorry, if it is lesser than pivot, If it is lesser than pivot, k plus plus. So let's go. Okay. So we were to find the smaller element so that we can put our element. So smaller element will be whatever be the position. So now the next thing would be the element which has got its position. So k plus plus is here. Now k has the count of number of elements is smaller than the current one. So what we can do is we can do the swapping. So the swapping goes something like array of array of the start. Array of start is basically the array of k. Okay, the array of k. So 0 to k plus plus whatever be the count over here. So that will be the array of start, and array of k would be is equals to array of k would be equals to whatever element is stored. It means the pivot itself. Now 5 calculated. So 5 just check the smaller element which is 4 and just swapped it. So it's the same thing I'm doing. So starting is swapped with k, which is the number of like the number of the point where we have to put our pivot element, right? So we have to put our pivot element over there. Now once it is done, so once the pivot has been given, only thing which is remaining is shift elements from both the ends. Okay, so int g and field. So int g is equals to start. Okay, and not this one. So j equals to start and k is equals to k equals to uh, k is already was at the pivot. So k plus one would be the starting index. K plus one would be the starting index. Okay. Now putting the smaller element on the left hand side. So putting the smaller element on the left hand side, it means that I not I um, j equals to start. Okay, so j should be less than j should be less than the partition. Okay, so j should be less than the j must be less than k, which is the pivot index, and okay. So L must be less than the n. Okay. Now we can just sub this part. So we can see that whenever we are having pointers at two places, two. So one is at two and one is at partition plus one. So one is at two, one is at partition plus one. So if the one is lesser than the current pivot, so while this is true, so array of array of j is less than, while array of j is less than the pivot. So continue. Elsewise, if array of j is less than pivot, do this. Otherwise, if array of L, so continue and j plus plus. So if array of the current element is less than the pivot, then I guess we have. to swap it. But how are we going to do that? Okay, so keeping your pointer at 2, keeping your pointer at 7. Now we are just comparing this, and if it is smaller, it can move forward. Okay, so if this is smaller, this can move the index, but for the cases like this one, okay, so it is at 8 and it is at 4. So what should be done? So 4 and 8 should be swapped. Okay, so 4 and 8 should be swapped. Array of L. Okay, and the logic can be, so if the current element is greater than pivot, so if it is less than pivot, is less than pivot. So we have to wait for an element. We have to wait for an element which is lesser than pivot. Okay, okay. So what are we missing? So one at two, and one at 7. So we want two pointers. And for comparison of, or let's one at 2 and one at 1, we need two comparison. So this would make sense. This would 2, this would 2. Okay. At 7, this is not less than 5, and the current is I. Okay, okay, okay. So what to do in this case? So okay, so two, we are following both the conditions. Okay, so answer L is less than pivot, and the current array of I, sorry, the J is greater than pivot. Then we can just swap it. All right, just swap it, swap this part. So we can say int temp is equals to array of L. Okay, now array of L is going to be equals to array of, okay, so are we having J? Yes, so array of L is equals to array of J, and array of J equals to temp. Temp will be the current element is storing it. Okay, I'll just change to this and just change to, okay. Anything else? No, it is just L plus plus and J plus plus. Okay, elsewise J plus plus, L plus plus, and continue. Okay, so J is less than K and L is less than N. Okay, J is less than, and I guess and has to be included, and same as true for K also. Okay, and JKL. LS K plus 1. So k plus 1. So L is k plus 1. Okay. And I guess we are good to go now. So finally, we can do this. So let's just reiterate through the logic. So pick an element which we call as the pivot. So pick element which we call as the pivot. Try to find the lesser elements which is then lesser than this. Place it at its correct position. So this 5 is at its correct position. Run two loops. Okay. So before you make another quick sort call, so learn. Like do two loops over the left hand side and the right hand side. So left hand side for the all elements lesser than 5, and this side for all elements greater than 5. Okay, so this is what I'm trying to do now. Find the pivot at the starting index. Find the pivot at the starting index. Get like whatever the values would be. Okay, and start with the environment. Start with the environment. Okay, so and finding the pivot position. So finding the correct pivot position means you have to check for like where. Okay, so where we can like put the things. Now array of i's is less than pivot, so we are just counting with the help of k, and once we have got the count, so we are just swapping the pivot element. Now the pivot element we have to do the swapping around it. So if j is already less than pivot, all good, and if it is l is less than like greater than the partition, right? So this is the only condition left. It's well and good. And if both the things matches, like L is less than pivot and J is greater than pivot, then we can just swap this part. Okay. And finally, we are waiting for a element. Remember, we are getting something partition over here. This partition is nothing more than the k which we are getting. The k where we are putting our element. That is the partition exactly. Okay, and I guess we are good to go. So we can check the algorithm out. So here is set it 0 to length minus 1. The starting is greater than end. Return partition array start index. Okay, so partition function, and then partition minus 1, partition plus 1. Okay, and here we go. Right, so right in the partition part. Okay, so array of the start placed with this, I guess. Okay, I guess it should be correct now. Just try to run this, otherwise we'll check for any issues. So these two algorithms are like very what you can say, like the solid use case for recursion. Okay, so it's saying unexpected return value and cannot be provided to int, cannot be converted to int. So it cannot be okay. Yes, thank you for the observation, man. This is nice. Okay, anything else we are missing, or we are good to go? Partition is called so cannot be void, cannot be converted. Okay, okay. I guess it's the same thing, right? So since we are getting the void in partition, so it was complaining about the same thing. Let's see. Let's see. And just so where we are lagging. So we have a stack overflow. Okay, makes sense because we may have missed any base case. So where is our base case? So 0 and array length minus 1, and here goes our base case. It says if it is greater than equals to en, return it. Okay. Okay, so do we have any here? No, we do not have there. So let's copy this and paste it over here. Not this one. So we just need this part. So mostly the stack overflow and these errors can come to the due to the base case. Let's see. Let's see if this solves our problem. So starting is greater than equals to index. En and we return. So I is equals to start plus 1, I is equals to n, I plus plus, that's it, k plus plus, okay. Start is equals to k is equals to pivot, and then I guess we are good to go. So j is equals to start and L is from this one. It should be less than the partition element and it should be starting or less than equals to the end element. Finally this j plus plus, and okay, let's try. If we get again we can just debug it. Okay, so what's the compilation? Missing return value. This is a concern. What should we return from this point? Since we have to return something, what should we return from this point? Okay, makes sense. What's in the base case? Right out, we do not need any base case over here. Do we need it? Or if we do, what should be returning? Hmm, what should we be returning? Okay. Let's put any -1 or something. Okay. Okay, here we go. Let's run this. Okay, it's again. Did we miss something? Okay, so one thing. Let's write the print statement over here. Area I. Okay. 0 element minus 1 to kick out, and this is this. So starting is greater than equals to en, then we simply return. Okay. Even if we do not need the equal to part, or do we need? Yes, we do need. So getting the partition from starting and end, then starting partition -1 starting. Okay. Hmm. So it should start from this part, okay, the second half, and then it should go to the end, right? Anything else? Let's have a final walkthrough. So we are getting this. So we are getting the pivot as the first element, okay. K equals to 0, keeping the counter starting from the start +1 till the end, getting it, okay, replacing the element to the pivot, starting starting the comparison part, and I guess it would do the job, right? Okay, so Stack Overflow is mostly related to recursion, right? So it's most of the time like, related to recursion. Okay, it's here again. Okay, this is really getting tricky. Did I miss something? So starting and end will be the partition part. So partition -1, partition +1. Okay, partition -1, partition +1. So let's change the name. That won't be the issue here. Okay, so getting the partition, and start should be, let's done it. Okay, this when I plus plus, so starting +1 pivot. Okay. J is going from start, L is coming from K plus 1, which is the greater index. J is less than and L is less than. Okay, so J plus plus and continue. Else, if this is the case and this is the case, it is going to be L is going to be J, and J is going to be temp. L plus plus, J plus plus, L plus plus, and finally we return K. Okay, okay, so what's the deal here? Mm, okay, so okay, okay. Let's see this. I will just check it once again. I guess it should be working because the algorithm has the same thing. Okay, I will make it a one more try then, and then we can discuss it. So till that time, if you like got the logic, then you can just go with it. I shall share this files. Okay, otherwise you can just go on and let's see this tomorrow. Okay, so let's continue on this part. Rest, I guess, after these two recursive algorithm, there are a couple of other problems we can solve using a string and arrays, and then we are fine with recursion. Couple of complexities like space complexity, time complexity, and rest of the things I guess would be clear. Okay, try it out. I will just check what's the issue we are having. Otherwise, okay, let's see that. Before you leave, guys, please mark the attendance. Where is the sheet? It's not this one. Okay, let me find the sheets of February. So it's Saturday today, and the date is 14th. That's 5. Okay. Please do not forget to mark the attendance. Here goes the link, and it's it. Okay, so please mark the attendance, guys, and let's meet tomorrow. Okay. Thank you. Thank you so much.